So I was studying about DVH today. DVH means dose volume histogram. So we know that our 3D planning, whenever we see a plan on a CT systems, we will kind of view it like this. So for example, this is an example of a glioblastoma case, a 3D plan. So this is an axial section where we can see that this green curve is 1 or 2%, and the red one is 100%. The yellow curve over here is 95%. The orange one is 60%, and the yellow one over here last is 20%. The same plan in the coronal section, and the same plan in the sagittal section. So here it's like the if you go slice by slice, you can see the whole plan in a 3D. But the same information, when it's drawn into a 2D graph, it's DVH, dose volume histogram. It's just 2D dose distribution for individual organs. So it does not actually replace the full isodose distribution, as they do not contain the geometric information. This will not contain the geometric information and cannot tell where the organ at which place of the organ is receiving what percentage. So a dose volume histogram will have dose is represented on the x-axis in gray, and on the y-axis volume is represented. If this is 0, 50 and 100% of the dose. Now DVH is divided into differential and cumulative DVH. So differential means frequency DVH, cumulative means integral DVH, the other names for these two types. So most commonly which we use is the cumulative. The most commonly which we use is the cumulative or integral DVH. So now differential, how does a differential DVH looks like? This is how it looks like. So dose on the x-axis and volume on the y-axis. So that will be one of the curve of the PTV. So it will show the minimum dose received by the organ or the PTV and the maximum dose. And for a PTV, it will show that whatever minimum width is there, the more good. So narrower the width of the peak, more good the plan is. Now, so this is an example of the differential DVH for other organs. So you can see that for PTV it's red and the narrower peak in the highest, and the dose, for example, this is a head and neck case. So the PTV is receiving around 66 to 70 gray. So and our OARs, normal brain, brainstem, chiasma, right ON and left ON. So for example, right is receiving around from 7 to around 15, to around 7 to 15. So our left ON, optic nerve, is receiving from around 3 to around 20. So brain, our chiasma, is receiving from around 50 to 30. So that percentage of volume, how much, like which is a minimum dose and the maximum dose, and what percentage of the volume is receiving how much dose. So for example, 10 to 15% of the volume of the optic chiasma is receiving 20 gray. So that's the differential DVH. So each organ you can say how much it is, but its differential DVH is mostly useful for the PTV, not as much as useful for the OARs. Now coming to cumulative DVH, cumulative just means integral. So you are just adding up the whole of the dose received by the organ. So it actually does not show you. So cumulative is useful for OARs and both PTV. It actually starts with 100% usually. So see, as you can see, it actually starts with 100% of the dose, and for each OAR or PTV, then it shows off where is the maximum dose received. So for example, wait. So this is usually our like a typical uh, DVH cumulative for PTV, and this is usually for the ORs. And we are trying to we are in a cumulative integral dose. We are see our ideal cumulative DVH should be the maximum for PTV and the minimum for our critical structures or ORs. This will be the ideal. So this will be the ideal cumulative DVH, but we cannot get that ideal situation. This is how our normal cumulative DVH usually looks like. So that's our target or PTV, and that's our critical structure which we are trying to avoid. So the more the curve goes downwards like this for the PTV, for the ORs, more good plan for the ORs, and the more it goes away, more good for the PTV. That's when the plan is better. So so this I showed is the DVH, differential DVH, the same represented in the cumulative DVH. So that's for the PTV. Now we saw here initially for the optic asthma, the blue one, here it starts from around 15 and it ends around 30, right? So here also 100%, like 100% of the dose, 100% of the volume receiving zero dose, and then as it goes from here around 15 to 30. That's the graph for the optic asthma. And PTV, it's receiving so much. So this is the integral cumulative or integral DVH. And cumulative or integral DVH is most commonly used to give PTV and OAR data. So the two most common uses of this type of DVH is for critical structures like spinal cord, we see maximum dose, so global maximum received by the organ for serial structures, and for parallel structures we see certain volume, for example in rectum in rectum, or like if you are taking lung, we see V20 of lung. So certain volume of certain organ we are trying to see.